Hi, this is Alexandros, and in this video, we'll be going over LeetCode 217, titled Contains Duplicate. This is a coding interview question that has appeared in interviews for companies such as Google, Amazon, and Adobe. Now, let's jump right in and start with the problem definition. The problem asks, given an array of integers, return true if any value appears at least twice in the array. Otherwise, if every element is distinct, return false. Let's now use a couple of examples to better understand the problem. When given this first array, we must return true as it contains number 1 twice. When given the second array, however, we must return false as all its elements are distinct. There are no duplicates. Let's now explore ways to solve this problem algorithmically. We might use a brute force approach to solve this problem, which could be as follows. Loop through the elements of the input array, and for each element, iterate over the subsequent elements in the array to check whether a duplicate value exists. Let's see how this approach would look like with an example. Given this array, we will start by taking the first element 1 and loop through the rest of the array to check whether another 1 exists. Since we haven't found another 1, we'll proceed by taking the next element in the array, which is 2, and we'll go over the rest of the array looking for a 2. Another 2 does exist in the array, and for that reason, we'll return true. The time complexity of this approach will be O of n squared. This is because for each of the n elements in the array, we perform a linear search over the rest of the array, which is an O of n operation. An O of n operation done n times gives us a time complexity of O of n squared. The space complexity of this approach is O of 1, or constant. This is because the space used is constant. It does not depend on the size of the input array. While the space complexity of this solution is excellent, the time complexity could be much better. For that reason, let's now look at an optimized approach solution to this problem that will have a better time complexity. We can solve this problem in one pass by using the set data structure. This approach would look as follows. Start by initializing a set that will hold the value of the elements we will visit. Loop through the elements of the input array, and for each element, check if the set already contains its value. If it does, it's a duplicate value and we can return true. If it doesn't, add the value of the element in the set. If we go over all the elements of the array and we exit the loop, it means that all the elements are distinct, at which point we will return false. Let's now use an example to see this approach in action. Using this array as input, we'll start by taking 1 and we'll check whether the set contains a 1. And since it doesn't, we'll add 1 to the set. Next, we'll take 2, and so we look for a 2 in the set. And since the set does not contain a 2, we'll add it to it. Then, we'll take 3 and check whether the set contains a 3. And since the set does not contain 3, we'll add it to the set. Lastly, we'll take 2 and perform a set lookup for the value 2. Now we see that the set does contain 2, and so at this point we can return true. The time complexity of this approach is O of n, or linear, which is much improved compared with our previous approach. We arrived at this time complexity because we look through n elements, and for each element, we check the set to see if we have encountered its value already, and if not, we add its value to the set. Set lookups and insertions, however, are O of 1 operations, and since we carry out O of 1 operations n times, we end up with a time complexity of O of n. The space complexity of this approach is O of n, as in the worst case, the set will contain n elements. Let's now look at a Python code solution using the optimized approach. We'll start by initializing our set, and then we'll start looping through the input array. For each element, we'll check whether the set contains its value, and if so, we'll return true. Otherwise, we will add the element to our set. Lastly, if we exit the loop, it means all the elements in the input array are distinct, and so will return false. And that's it. Now that you know how to approach the contains duplicate problem, try coding up the solution by yourself, or better yet, try coming up with other algorithms that solve this. If you have any feedback for this video, please leave a comment down below, and don't forget to like and subscribe if you want to see more of these. Thank you for watching. This has been Alexandros with alexandros.io.